Hello. Today in this video we are going to start a new topic, and the name of this topic is Bernoulli trials and binomial distribution. Now to start this chapter, we will first study Bernoulli trials, and to understand this Bernoulli trial, we'll look at a small situation. So in this situation, suppose that you have an exam tomorrow of mathematics, and by mistake one night ago you studied physics. Now you enter an examination hall where you are sitting in your desk and you get a question paper which is of mathematics. Now suddenly you are in shock and you don't know how to answer all these questions. Now all these questions are 5 multiple choice questions, each having 4 options, and out of those 4 options only one of them is correct. Now the answers, the way you're going to attempt this question is very random. Since you don't know what is correct answer, so you'll mark option randomly. So in that scenario, either you will get a correct answer or you'll get an incorrect answer. So now at this point we will define 2 new terms. One is success and another one is failure. So success in our case is getting a correct answer. That is, if you take an answer if you choose one option, then that option is correct, is a success. And if you choose any option and the option chosen is incorrect, then it's a failure. So failure is getting an incorrect answer. So in this case, the probability of success will be 1/4 and probability of failure will be 3/4, because there are 3 incorrect answers. Now, why did we define success and failure here instead of 2 events? So the importance is that in many of our real life situations, there are 2 outcomes. So if you toss a coin, suppose you toss a coin and the outcome you get is a head, then another outcome that you will get is a tail. So here are only 2 outcomes possible, head and tail. So in such cases where there are only 2 possible outcomes, you define terms success and another one is failure. So if you get a success, then there's no possibility of getting a failure, and vice versa. So in this case also we defined 2 outcomes, success and failure. So if the option is correct, then it's a success. If it's incorrect, then it's a failure. Now I want you to pause the video here, write down all this whatever written on the board, and then we will continue with this Bernoulli trial. Before we move ahead with concept of Bernoulli trial, let's ask ourselves a simple question. What is the meaning of trial? So every experiment itself is a trial. For example, if you perform an experiment of tossing a coin in the air, then tossing a coin itself is a trial. If you repeat the experiment second time, it will be trial 2, and if you repeat the experiment third time, it will be trial 3. So in this case also, where we have 5 questions, attempting each question in itself is a trial. So if you attempt question number 1, it will be trial 1. If you attempt question number 2, it will be trial 2, and so on. If you attempt question number 5, it will be trial 5. Now when will all these trials be termed as Bernoulli trial? So for any trial to be a Bernoulli trial, 4 conditions must be satisfied, and first condition is number of trials should be finite. So in our case, where we have 5 questions and attempting each question in itself is a trial, so we have 5 trials. So since 5 is a finite number, we can say that in this case first condition is satisfied. Now second condition says that trials should be independent. Now attempting each question in itself is a trial. If I attempt question number 1, then it won't affect attempting question number 2, 3, 4 and so on. So attempting of each question is an independent activity. Hence we can say that in this case a second condition is satisfied. Now third condition says each trial has only 2 outcomes, either success or failure. So in this case each question has only 2 possible answers, either correct answer or incorrect answer. So our success is getting a correct answer and failure is getting an incorrect answer. So only 2 outcomes are possible here, either correct or incorrect. Hence third condition is also satisfied in this case. Now fourth condition says probability of success remains same in each trial. So in all these questions we have 4 options, and out of all those 4 options only one option is correct. So probability of success is getting a correct answer, hence it is equals to 1/4. In second question also, probability of success is 1 by 4. In all the questions, in fact, probability of success is 1 by 4. Hence, since probability of success in each question or in each trial is same, we can say that fourth condition is also satisfied in this case. So since all these conditions are satisfied in our example, we can say that it's a case of Bernoulli trial. Let's say now you have done the exam and you have solved all the 5 questions, and you get this announcement that if you solve exactly 2 questions correctly or at least 2 questions correctly, then you can pass the exam. So now you must be wondering, if you have passed exactly 2 questions correctly, then you may pass the exam, and you would like to know the probability of answering exactly 2 questions correctly. So in how many ways you can solve 2 questions correctly? Either you can solve first 2 questions correctly and remaining 3 questions incorrectly, or you can solve first question correctly and fourth question correctly and remaining 3 questions incorrectly. So in 5C2 ways you can solve 2 questions correctly. Now you want to know the probability of solving 2 questions correctly. So we know that solving each question is an independent event. So to find its probability, we can simply multiply individual probabilities, that is P of S into P of S into P of F into P of F and into P of F, where S is success and F is failure. So 5C2 into P of S square into P of F cube will be the probability, and we know that P of S is equals to 1 by 4 and P of F is 3 by 4. So the probability becomes 5C2 into 1 by 4 square into 3 by 4 cube. Now, similarly, you can also find probability of solving one question correctly. So in 5C1 ways, you can solve one question correctly, and probability will be P of S into P of F raised to power 4. So this becomes 5C1 into 1 by 4 raised to power 1 by 4 into 3 by 4 raised to power 4. And similarly, you can find the probability in other remaining 4 cases. So total we have 6 cases here. And now if you look at these terms very closely, the first term is 5C0, then this term is 1 by 4 raised to power 0, and this term is 3 by 4 raised to power 5. Now if you consider expansion of x plus a raised to power n, and if you write the general term of this expansion, then we have tr plus 1 ncr x raised to power n minus r into a raised to power r. Now for a moment, let us assume that in this case x is 3 by 4, a is 1 by 4, and this n is 6. So this becomes 6cr 3 by 4 raised to power 6 minus r into 1 by 4 raised to power r. Now if you put r equal to 0 in this term, then you get this term. And if similarly if you put r equals to 1 in this term, then you get this term. And similarly, if you put all the values of r equal to 2, 3, 4, then you get all these remaining terms. So in short, we can say that all these individual terms are terms of binomial expansion. So the binomial expansion of this is the binomial expansion of 3 by 4 plus 1 by 4 raised to power 5. Now we know that 3 by 4 plus 1 by 4 is equals to 1, and from here we can say that sum of all these probabilities equals to 1, and this is binomial distribution of all these probabilities. So in binomial distribution for the probabilities, we can represent each case with a particular term of a binomial expansion. So this was particular case of binomial distribution. Now we shall generalize it. Now let us define general case of binomial distribution. Here we have an experiment which consists of n number of Bernoulli trials, and in this case probability of success is small p and probability of failure will be 1 minus p, that is equals to q. Now if you want to find out probability of 0 success, probability of 1 success and probability of n number of successes, then we can find this using binomial theorem. That is, we can write this as q plus p raised to power n is equals to nc0 into q raised to power n. This is the probability of 0 success plus nc1 q raised to power n minus 1 into p. This is the probability of one success plus this is nc2 q raised to power n minus 2 into p square. This is probability of 2 successes and so on. ncn into p raised to power n. This is the probability of n number of success. So if we define a random variable x where we say x is number of success, and if we want to find out probability of x number of successes, then we can find it using this expression, that is p of x equal to x ncx into q raised to power n minus x into p raised to power x. So this is general case of binomial distribution, which is only valid for Bernoulli trials.